Here's an example of a problem from the 2002 AP Stats exam where you're provided a scatter plot, some narration, and a computer output. And you're to answer questions regarding these given items. So let's read this. Commercial airlines need to know the operating cost per hour of flight for each plane in their fleet. In a study of the relationship between operating cost per hour and number of passenger seats, investigators computed the regression of operating cost per hour on the number of passenger seats. The 12 sample aircraft used in the study included planes with as few as 216 passenger seats and planes with as many as 410 passenger seats. Operating cost per hour ranged between $3,600 and $7,800. Some computer output from a regression analysis of these data is shown below. So we see the scatter plot, and we see that there is somewhat of a linear relationship here. Doesn't look like really there's a curve to it at all. Looks like if we were to have a relationship, it might be linear. We aren't given a plot of the residuals, so we wouldn't examine that. We're going to take the information from the problem and use what's given to us. We can see that we have number of passenger seats on the x-axis and operating cost per hour on the y-axis. So our explanatory variable would be the number of passenger seats, and then our response variable would be the operating cost per hour. Here in the computer output, we see that we have the coefficients, and the constant is 1136, and the slope coefficient for the number of seats is 14.673. We also have standard deviations, and then we're provided with some other output here that we'll talk about later in a later module. We also have this r-squared value, which is going to come into play here. The first question is, what is the equation of the least squares regression line that describes the relationship between operating cost per hour and number of passenger seats in the plane? Define any variables used in this equation. So we're to write out the equation of the least squares regression line, and that would be in this form: y hat equals a plus bx. So we talked about a second ago that our response variable is the cost. So the predicted cost values would be found by 1136. That is the coefficient of the y-intercept, plus, now the slope coefficient for the number of seats is 14.673, times the number of seats. And we could write this maybe like this, implying that we'll multiply this number by the number of seats. Another way this could be done might be to say y hat is equal to 1136 plus 14.673x, and then define what these variables actually are. Y hat, you could say, is the predicted operating cost, and x is the number of seats. So that would be how we would answer the A part. The B part says, what is the value of the correlation coefficient for operating cost per hour and number of passenger seats in the plane? Interpret this correlation. So for the B part, what we're given is r squared. And we're given that it is 57%. And this 0.0 is important. 0 is a number. We wouldn't want to leave that off. We're implying a certain rounding precision here. Now, in order to find r, then, all we would do is find the square root of 0.570. And rounded to 3 decimal places, that would give us 0.755. We are to interpret this correlation, and there's a couple of ways that we might do that. We might say that there is a moderate to strong relationship between the number of seats and the operating cost per hour. Something else that we might mention in this analysis is that since r squared is 57.0%, we could say that 57% of the variation in operating cost per hour can be attributed to variation in the number of seats. The next question says, suppose that you want to describe the relationship between operating cost per hour and number of passenger seats in the plane for planes only in the range of 250 to 350 seats. Does the line shown in the scatter plot still provide the best description of the relationship for data in this range? And we're supposed to specify why or why not. So if we were to remove any points in this scatter plot that have x-coordinates of less than 250 or greater than 350, then we would be removing these 2 dots and these 3 dots. Here's 250 and here's 350. And that would leave us with just this data grouping here. And this appears to have a negative slope. As a matter of fact, it's nothing like what this original line looks like. So to answer this question, we would have to say something along those lines. Something like eliminating the data values outside of the range 250 to 350 would leave a scatter plot that would appear to have a steep downward trend. This would result in a regression line with a negative slope, or imply a negative correlation between the number of passenger seats and the operating cost per hour.